this was that professors oftentimes are older people. People that are running departments, people that are at universities and they run laboratories. Those are typically older people. They're 40 and up. But the people that are actually coming up with the new ideas and designing the new experiments and asking the new exciting questions and then actually doing the work, those guys are young people. They can be as young as teenagers. If you think of a scientist is somebody who does science, and that means they use the scientific method. And that can be anybody. You don't need an advanced degree to be a scientist if you're studying science. One of the things to look at when you think about the scientific method, right? You guys have all heard observation, hypothesis, design the experiment, run the experiment, do the analysis and the conclusions. Well, if you really think about it, that's just learning. Like, that's a really formal way of saying I'm learning about something. So every single one of you, from the time that you were babies, has been using that process to learn about the world around you. If you think about how you learn to walk and how you learn to talk and how you learn to make your way in the world, those are all things that you had to use those same skills, that questioning and making hypotheses and making observations again, drawing your conclusions, trying the experiments, all of these things. You might not have done it in the exact order, but you did all of those things so that you could figure out how to make your way in the world. So the big thing that I want to talk to you guys about, since you guys are working on your book of questions this week, is how do you ask really good questions? And it's one of the things that is, a little bit less known. So, I've talked to a lot of kids in STEM classes all over Coppell now, and if I ask you guys, what's a creative subject that you study in school? First thing that comes in your head, raise your hand, let me hear it. What's the first thing that comes in your head if I say a creative subject that you study in school?
Writing.
Writing, okay, that's a really common one. Art, really common one. Anybody else? Band, so music, yeah. Anybody in theater or drama? Anybody in dance? Anybody? No? Okay, so those are the ones that are most commonly thought of as creative subjects. But one of the creative subjects that I think of all the time is science. Science is actually a very creative subject, and it's very hard sometimes to see where that is, because a lot of times you see, they're doing, the button washing and bottle sorting, or I guess bottle washing and button sorting, whatever it is they call it, They're doing meticulous things, and they're looking at numbers. And that doesn't seem very creative, but being able to ask the right questions is one of the most important things that you can do in science. And that's one of the hardest things to do. So there's an art to learning how to ask good questions. And the way that I always try and start is I try and start with something really big. And the first question that I can remember asking that was a really big science question, I was about 7 or 8 years old. And anybody here interested in Greek mythology? Because I was a total Greek mythology nut. Anybody like Percy Jackson? I know we got some Percy Jackson fans. See, I say Greek mythology, nobody raises their hands. I say Percy Jackson, everybody does. I was really interested in satyrs and centaurs. I thought that they were really cool critters, like you've got this half man, half goat, or this half man, half horse kind of thing. I said, Dad, is that even possible? Can you mix and match, different pieces of different things and make something new? And, I said before, my dad is a huge sci-fi fan. My dad's a huge science fiction fan. And I'm a big sci-fi fan as well, but because of that, he had a really good answer for me. He says, yeah, that's a field called genetic engineering. And it's really new. It's something that hasn't been around for very long. Well, many years later, that's the field that I ended up going into in science. I never would have expected that was the field I would have picked. As a side note, anybody in here science fiction fans? Maybe like Ender's Game or any of the really great sci-fi books? Keep reading sci-fi, because if you want to be a scientist, that is the stuff that you will be working on. I'm not kidding at all. The stuff that I was reading as a kid in science fiction, half of that stuff is what I ended up working on. So it's not that far out. It's not that far-fetched. So I started with a really big question, right? I'm 7, 8 years old. I don't know anything about science. I'm asking, can I mix and match pieces and parts of different organisms? Well, many years later, when I went to graduate school, I had a chance to start asking that question again. And rather than doing it in, humans and goats or humans and centaurs, it was really things like jellyfish and bacteria or fish and mice and things like that. But it was mixing and matching little bitty genetic parts of different organisms. But what I wanted to say is you start with that big question. The second question that I almost always think is a good idea to ask in science. Actually, and it's not even the second question, it's the second through 100th question, is this even a good idea? Is this the right thing to do? Is it ethical? That's one of the things that always has to be asked in science. Anybody know who J. Robert Oppenheimer is?
He was one of the people that worked on the Manhattan Project.
Yes, so the Manhattan Project, for those of you that are not familiar, is the project that resulted in the atomic bomb. J. Robert Oppenheimer was one of the great minds in that project. And if you think about it, before the technology for nuclear physics and nuclear chemistry was used to create a bomb, there were ideas that could be used to be an endless source of energy for us, so that we could get away from fossil fuels. But there's also this other use that it was used for, and there were 2 atomic bombs used against people in history. So you always have to ask that question of, is this even an ethical thing to do? As you're doing your experiments, you should always keep that in mind. But as you go from your big question and you start breaking it down into smaller and smaller questions, you can start asking, well, is it a good idea? Like, is this even useful? And my logic for why I went into genetic engineering or synthetic biology. Synthetic biology. So do you guys know what synthetic means? Anybody know what synthetic means?
Artificial.
It means artificial. Biology is the study of life. So synthetic biology is the study of artificial life, which is what I was working on. I was working on creating artificial genetic circuits in bacteria. I was creating a new species of bacteria, basically. I'm lazy. I don't know if any of you else have that bug. If I can get something else to do something for me, I will do that every single time, and that's why I was using bacteria to do a job for me. So that's what I wanted to do, is I wanted to create a bacteria that was useful and could do something beneficial. And right now there's a lot of work being done on using bacteria to clean up spills. So like, do you guys remember when there was a big oil spill in the Gulf of Mexico here recently? One of the things that was considered being used, and it works really, really well for oil spills, is bacteria that will eat all of that oil up and turn it into food for other things. That was an option that was being considered because they were already developed. So bioremediation is one field where synthetic biology is really coming to use. Biofuels is another. So biofuels is made out of life, and it's a fuel trying to get us off of fossil fuels. So you guys are familiar with ethanol or corn being used for additive for gasoline? There's other biofuels out there, and some of them are way better than ethanol. They don't take as much energy to make. They're more efficient. You can make propane or natural gas or biodiesel. There's all sorts of other different fuels that you can make. But that's another big use for synthetic biology. Mine was in medicine. So I wanted to create a bacteria that was useful to treat an illness in people. Now, I say I'm going to create a bacteria that's used for medicine. How many of you think that germs are bad? Bacteria are bad? Anybody? Anybody? All right, awesome. I am glad that I didn't see any other hands go up. Bacteria are actually one of our greatest allies in the world. They're a symbiote with us more often by far than they are a pathogen. Do you guys know what a pathogen is?
A virus.
Okay, a virus is always by definition a pathogen. But if it's a bacteria, can it be a pathogen? What do you think?
Well, it can be, but
It can be, but not necessarily?
yeah.
Good, perfect. So a pathogen is something that makes you sick. That's all it is. And some bacteria are pathogens. So you've probably heard of E. coli outbreaks or salmonella or typhoid or different things like that. You've probably heard about the plague in history, all caused by bacteria. But more often than not, you have bacteria that are living in and on you that are helpful for you. So there's a really great scientist. She's a rock star. She's one of my science heroes. Her name's Bonnie Bassler. And she gave a TED Talk where she talked about bacteria that live in and on you. She said if you count every cell in your body, you count all your muscle cells and your skin cells and your nerve cells and your kidney and your liver, you get a number that's about 1 trillion. It's a big number, right? It's like 12 zeros after the 1. If you count the number of bacteria that live in or on you, it's about 10 trillion. So there are 10 times more bacterial cells on you than you have cells of your own. So if you go by the sheer number of cells, you're actually more bacteria than you are people, which is kind of a creepy thing to think about, right? You're like a walking incubator. You think of yourself as a person, really, you're walking around and you're more bacteria than person. It's kind of crazy. But there's a lot of these organisms that are really good for you. So anybody like yogurt? Anybody a yogurt fan? I'm a big yogurt fan. Keep your hands up. How about cheese? Cheese, kimchi, kombucha. Any other fermented foods? They're all really good sources where as you're eating them, you're eating billions of bacteria at a time. You're filling your body up with tons and tons of bacteria. Really good sources for you, and they're very healthy for you, as a matter of fact. What I wanted to do is I wanted to make one more that was like that. One more bacteria that lives in you that's helpful. But what I wanted to do is I wanted to rearrange its genetics in such a way that I could make it be useful for a specific disease. So I started asking, big question, how do I mix and match parts? How would this be useful? Well, maybe we can do something with bacteria. Bacteria are good in or on you. And specifically, where would they be good in your body? If I was to inject bacteria into my bloodstream, how well do you think that would turn out? Good thing or bad thing? Bad, right? It's called sepsis when you have bacteria in your blood. It's not a good thing. Even things that are normally helpful for you, if they get into your blood, probably not a good thing for you. But what I wanted to do is I wanted to design a bacteria that could be in a good space where it could help. So I said, all right, let's look at the intestines. What are some of the diseases that happen in people's intestines? You've got bowel cancer. You've got all sorts of irritable bowel syndromes. There's also one that's called inflammatory bowel disease. And when we looked at inflammatory bowel disease, we started reading more about it, and we found out, one, it's a disorder that doesn't have a very good treatment right now. Most of the ways that you can treat this disease, they've got really bad side effects. Really, really awful side effects. Inflammatory bowel disorder has a lot in common with asthma. Anybody have asthma in here? Anybody? So it's really, really not fun to have. With asthma, you go long periods where you're not having an asthma attack, so that's called a remission. And then you'll have a flare-up, where all of a sudden you have an inflamed process going on in your lungs, and it starts tightening up your airways and you can't breathe. And that's when you've seen the rescue inhalers, the little puffers. So what that's for is it gives you medicine directly into your lungs to try and make that inflammation go away. Well, in inflammatory bowel disease, it's actually very similar. You have long periods where you're in remission, and then you have flare-ups of the disease where it'll last for days or weeks, and it's very, very painful. It's incredibly painful. You'll see patients doubled over. They've got blood in their stools. It's crippling pain. It's really, really unpleasant for these patients.